In order for us to see something, we need to emit light directly like the sun or anything else. That means we have to absorb photons of light directly into our eyes. But we know that light is a wave particle, so how can we see it? Of course, you can't bounce light off of light, just you can't bounce sneaky waves of each other, they just pass right through. Plus, if we look in a photon of light in the normal way, that means your eye or camera will absorb it, and then it's gone destroyed. It's exactly like you want to test how much weight a bridge can support before it falls down. Once you've done your measurement, you have the information you wanted, but you no longer have a bridge. So, in order to see light, we need to use non-destructive testing. One way of doing that is to make a super dark, super cold box and cover the inside with a really shiny mirror. A mirror so excellently reflective that photons of light bounce back and forth. This box is also so cold and dark that only occasionally will there even be one photon inside. Well, to detect this photon, we send an atom through the box, an atom in a superposition of two different atomic states. So, if there is no photon inside the box, then the atom comes out in the other side. We will most likely measure it in a certain one of the states. Let's call it X. But there is a photon in there, and we carefully send the atom through. It doesn't actually destroy the photon. The atom-photon interaction changes the odds, so now it's an overwhelming chance to see that atom as Y. After sending a few atoms and they comes out in the Y states, then we know there is a photon in the box. It's kind of like sending a pinwheel through a dark room, and if it comes out and the other side spinning, you know that the wind is blowing. If not, no wind. In fact, once we know there is a photon in there, we can use this technique to measure and manipulate many other things about photon, like we can see how long it bounces back and forth before it gets absorbed. And also, we can check if it's in superposition and even force it into a superposition, just like Schrödinger's cat. So, not only we can see light, but now we can measure Schrödinger's cat superposition. By the way, the person who discovered this method are Serge Harosh and David Weinland, and they won the Nobel Prize in Physics in 2012. Goodbye!